ask, I think one important distinction here, from what I can understand, Sir Roger, is what the nature of understanding is not to be simply reduced to belief or intuition, though it may be related to them. When one understands something, let's say that's the simple equation that 2 + 2 = 4, it's not a belief that that is true. Understanding is operating at a level that is beyond belief. It has a certainty, an inner certainty that is not subject to doubt fundamentally. And what I was wondering if it might be helpful, just for the sake also of the people who may subsequently watch this conversation, if you would be willing, Sir Roger, to give us a sense of the way you describe the 3 spheres of matter and mind and mathematics, as that might give us a basis for some quite rich conversation subsequently.
Well, maybe. You want me to describe the picture? I mean,
Please.
Well, this was just a way of thinking about the relationship between mathematics and the physical world and the world of conscious perception. And I was regarding each of these as a sort of world. I mean, whether that's a useful way or not, it was just helpful to me. And there is the mathematical world, and I take a very Platonic view here, that the mathematical world exists independently of us. And so when we find a mathematical result, it's more like a discovery than an invention. So it's there already, and you find it. So this is certainly a feeling that, as far as I'm aware, most mathematicians have. And the truths are there, and they're there independently of us. And if we're lucky, we can find one of these truths and see why it is a truth. Now, that's one thing. Now then there's the physical world. And the physical world, the more we learn about it, the more we find that it operates according to very precise mathematical laws. But yet it's very small. You see, if you look at a mathematical journal, you find it's almost entirely full of things which have nothing whatsoever to do with the physical world. They're playing around with mathematics for its own sake. That part of the mathematical world, which actually does have direct relevance to the way that the physical world operates, is a small part of it. So I have a picture of this mathematical world, and a tiny bit of that comes and imposes itself, or whatever you like to explains, or whatever you like to say, the physical world. So the more we learn about the physical world, the more we see it is driven or acts according to these very specific, tiny part of the mathematical world. And the second thing is, in that physical world, which seems to be operating according to mathematics, there are entities which seem to be able to perceive and understand and have consciousness. So the acquisition of consciousness in whatever way is a small part. You see, the world consists of rocks and things like that, which don't seem to have any of this quality. But there are certain creatures, things, such as people in this room and elsewhere, and probably other animals which may have less of it than humans, but on the other hand, I certainly think they have consciousness, some of them. So, but still, it's a tiny part of the physical world which seems to have access, or whatever the right thing is, seems to be able to be, in a certain sense, this world of consciousness. So it's again a small part of that. But it's only a tiny part of the conscious activity which is concerned with mathematics. So I had this picture which is sort of meant to be slightly paradoxical, that each world, in a certain sense, comes from a little bit of the world preceding it. And so it's drawn in a way which is like this impossible triangle, which is looks like a paradox. That's only a little joke in a way. I don't know how much depth there is to that. And I rather like to depict it in that way.
So so stop me when I'm wrong, okay?
Well, anyway.
All right, so it seems to me that the mathematical reality is something like the observation of the patterned regularity between things. It's not the things themselves.
Oh, the physical, which way?
Well, I'm thinking about the mathematical representation of the physical world. So, because things, there are things, obviously, but there are things in relationship to one another.
Yeah.
And the relationships between the things, like the pattern that your tiles compose, is just as real as the tiles.
Well,
right? But it consists of the relationship between the tiles. And is it the representation of the relationship between things that's part of that mathematical world, rather than, I know it could be patterns all the way down in some sense.
You see, that it's a physical thing. It's just sitting in front of a mass building. So that's a physical thing. But it represents a mathematical idea, which only gives you the idea. You could say, oh, these tiles fit together in such and such a way, and these are parts of a Euclidean plane, and the Euclidean plane is a concept. We don't actually have it physically, but you can see, by looking at the tiles carefully enough and see how they fit together, that this is a mathematical thing you're looking at, in a way, and that this mathematical thing would allow you to continue, if you understand what's going on, indefinitely. So the entire Euclidean plane could be covered according to the rules of those shapes you see.
Okay, so let me ask you another question about that then. So, is the physical world one tiling solution to the plane of mathematical possibility?
I guess in a sense. I mean, it's slightly, you see, it's not really talking about the laws of physics there. It's only in the sense that Euclidean geometry is a pretty good approximation. That's all it's saying. I mean, there's not much physics going on there. You might say, well, what makes these tiles, some of them shine and some not shine, or something like that? I mean, that's more like physics. But the actual design that's being used there, it's been put there by human beings according to what another human being said the way they should lay them down. And that was driven by a certain mathematical concept. But it's different from the way that mathematics underlies the laws of physics. That's quite different. It might be if you took one of those tiles and threw it across, well, it would be pretty hard to do because they're quite heavy. But the way that would move in the air before it came down and crashed, that would be a clear indication of a physical law, the way in which gravitation behaves. And then the way the thing holds together, the law that makes these tiles solid, be something to do with the quantum mechanics, to do with the ways that the atoms are constructed and how they connect with other atoms and what makes them solid rather than a fluid, or something like that. So that would be the way that mathematics drives the physics. It's general laws rather than a specific thing. I think that's
I'm
what I'm trying
curious
to say.
to it, because in some sense, and I could obviously be wrong about this, but the physical reality seems to constrain the mathematical possibility, because there's only some mathematical rules that govern the behavior of actual objects, even though there's all sorts of possible mathematics that could govern the action of all sorts of hypothetical objects. Right? So imagine if there's an underlying, I can't help but think that this is associated with this many worlds idea, but if there's an underlying metaverse of mathematical possibility, you get the emergence of something like, well, what would you say, one concretized exploration of that possibility space, and that now establishes a relationship between one element of that mathematical possibility space and well, in reality itself. Doesn't exhaust the search space, but it seems to me that that's analogous to this tiling problem in some sense.
I think it's I don't know, I can't help saying I think it's really very different from what one is trying to do in mathematical physics. See, in mathematical physics, you're looking for general laws which seem individual instances of it agree with those laws, so that an object like one of the tiles that are being used outside mass building, I mean, the trouble is that it depends on detailed laws about the atoms which construct the tiles and so, which has nothing to do with what we're talking about here. I don't think it is.
Well, I guess I was wondering partly because there's these fine-tuning arguments, and the question arises, well, there's lots of ways these phenomena could be interrelated, but in reality it turns out that there's a very finite and constrained number of ways that they are actually related, and those are the fundamental laws. And then the question arises, well, why that set of constraints and not some other set of constraints that seems equally probable statistically, if it was a sample of the mathematical domain?
Yeah, I guess I have to understand what you're saying a bit better. You could say, okay, there's this building, well, the one we're in now, which has in the front of it a certain tiling. That's, if you're going to explain that, that's very different from what mathematical physicists do. They're just looking for general principles.
Right.
And as far as we're aware, those general principles are not violated in what's been going on in this building. However, that's not entirely what I would think, because what's going on in this building and so on is an implication of what's going on in people's heads. And this does have to do with consciousness. And what's going on in consciousness, in my view, is not yet part of current physics. So I'm trying to say that although we have very good theories about how things behave, bodies behave, they're not good enough yet to tell us how the conscious human brain operates.